Let's see the third chapter of this module. So this is all about protocols. Protocols are communication means. So rules, how these rules are used in networking. So in this topic, there are some topics. What is a rule? The protocols. What are the data encapsulation and data formatting. So how are actually devices communicating using these protocols? So what's the rule? In any communication, you need a rule. So if there is a sender as well as a destination receiver, they have to first agree on the rule or on the communication media, on the way, on the how they are going to communicate. Similar to networks in human, we have what you call rules. So when we communicate, for example, we may ask for time or for directions. First, we greet them, we say hi, how are you, and then we ask them, and then they can silently or in a good mood they can reply what they have been asked. So the same rule applies to actually to the networking. So there is what we call rules in HEMAS. The same rule has to be applied in the communicating devices. So rules have to be established. So first, there has to be an identified sender and receiver. It's clear. So that they have to use some language, so common language. For example, if I am speaking in English and that guy is speaking in another language, we cannot communicate. So at least they have to agree in the language, and the speed is necessary. For example, very speedy, and that guy may not understand what I am talking about. So there has to be also a confirmation of that acknowledgement, or whether you have finished your talk or. So these are rules in the real life in humans, and the same thing also applies in the other devices. So in network protocols, one, the message encoding. What type of communication are they using? What type of encoding is being used? Format. How is it encapsulated? What is actually encapsulating the data? What type of coding is it using? Message size. How much is the size? In what bits are the beginning bits, the end bits, and in between what is the protocol being used? Timing is critical. For example, when you communicate with servers can be fast, but the server has to actually adjust its timing with the client. Message delivery options. You have to say, for example, acknowledgements. You have to say goodbye, I'm done, or finished. So these acknowledgements are important also in protocols, in communicate protocols. So when these devices are communicating, they have to actually first agree on the protocols. What type of message is it? For example, if it's an image, what type of image is it? So if this viewing of an image is different within this the destination and the source, they cannot the destination cannot understand what that format is. So the format of that is in the application layer. So they have to agree in all layers what the protocol is being used. So first it has to be encoded, and then when it is decoded as a receiver, it has to follow the same principle as what you call the encoding, and they have to agree on these protocols. So when we encode, for example, you have got this is an IP packet, 40 byte IP packet. There has to be a source IP address, destination IP address on the packet. On each packet, we have to have this what we call source and destination IP addresses, because The source and the destination has to be known, otherwise they cannot communicate. You see, other headers here are for other communication means. They actually transmit some information. Traffic class, flow level, payload length, for example, what is the length of the data. Next header, when will hop limit, how many hops the packet should actually propagate. After some hops, commonly 10 or 11 hops, the packet has to be dropped. So size is important. Big data should not be sent at a time. It has many implications. One, for efficiency purpose. So how the efficiency, if for example, if you have big data in one packet, if you transmit the whole data and there is one error, a single bit error in some part of the data, you have to retransmit the whole data. If you chunk it or break it into many pieces, you see, if one bit of error is in one piece, you need to retransmit that piece only. So this messaging is also message size is also critical. The destination and the source have to actually agree on the message size. The protocol. If the protocol is known, the message size will be known actually. Flow is important. Flow control. So how fast is the sender sending? The response time. For example, if you send some message and you don't receive any acknowledgement, it has to be dropped. After what time? The timing is necessary. What access method are they using? If there is, for example, collision, if we have what you call shared media, the shared media, there could be some collisions. So after collision, what will happen? What time should they follow? There are many protocols for this collision prevention and collision avoidance or collision detection techniques, and they have to agree on these protocols. So you can have different ways of message delivery. Unicast is from one-to-one communication is called unicast. Multicast, one to many devices. Broadcast is one to all. If it is a broadcast, it is to all devices. If they are in the same broadcast domain, every device will actually receive a broadcast message. So this is one-to-one, one-to-many, and one-to-all. Sorry. Next is what are real protocols we have. So network protocols. Where are these protocols implemented? Most of the time, either in software or hardware part. Commonly, above the MAC layer, the protocols are implemented in software. MAC sometimes in hardware, sometimes in software, or mixed both. So you know the 7 layers OSI layers, or TCP/IP layers. The first layer, the physical layer, and the MAC are most of the time implemented in hardware. From the MAC above, everything is implemented in what we call software-based implementation. So network protocols, they have some implications in addressing, reliability, flow control, sequencing, order of delivery of packets, error detection, because that is critical. If there is some error, what do you do? Are you going to retransmit or use some mechanisms of error detection techniques, applications in the application interfaces? For example, if there is some process communication between network applications, you need what we call protocols in the application layer. So the application layer, so for viewing any message, for example, you may have JPG or MP4, such kind of applications. They have to use some rules or protocols for communication. So protocols, where do they interact? For example, if you have, this is a TCP/IP protocol, the Ethernet is the lower layer, which is the MAC layer. We have got the IP, TCP, HTTP. In every layer of this, you add actually some protocols. Ethernet layer protocols, there are a lot of Ethernet layer protocols, IP protocols, some few TCP IP protocols, TCP protocols. HTTP is application protocol. HTTP is one. There could be a lot of applications, but a hypertext transfer protocol is a very common, especially for web. It is common. The TCP is transmission control protocol. There is a UDP part of that one. We will see it later. The IP is one that is very common in the internet protocol that delivers message globally from network to network. You need the IP for interconnection. The Ethernet is for local area communication. That is, devices in the same network has to communicate using this Ethernet layer. But even in the same network, every part or every layer will be actually investigated. But the Ethernet is commonly the NIC, the interconnection between two devices. It is critical in this switch or hubs or layer 2 devices. They use what you call Ethernet. If it is Wi-Fi, also wirelessly, Wi-Fi is the layer 2 protocol, which is called Ethernet protocol. So what are the protocol suites? Common protocol suites. So protocol suites, one is the TCP/IP, which is very common, actually invented by the American defense. It was hidden for some time, and I think it is now public. It is public. It was invented actually in the military. Then we have the very common OSI, open source, open system interconnection, OSI protocol. Apple Talk is actually proprietary for Apple. Novell, that one is also for Novell for industries for industry-based applications, what you call seeds. So the TCP/IP is very common, very common. So in the TCP/IP you have got 4 layers: the network access protocols like Ethernet, ARP, WLAN are the lower layer protocols. You have got the internet, which is IP, actually IP protocol. So you have IP version 4, ICMP, layer 3 protocol. It's sometimes called layer 3, but this is the internet protocol. We have got the transport. We have got two protocols in the transport protocol, the TCP and the UDP. TCP is connection oriented, that one is connectionless. And the application layer, there are a lot of application layer protocol. HTTP is one, DNS, domain name service, HTTP, dynamic host configuration, FTP, very common protocols in the TCP/IP. OSI, sometimes they call it ISO, is also, they do have many protocols. Apple Talk is another protocol. But this is protocol suite. Protocol is important. Protocol suites are actually standardized. Standard is important. So you come to the common understanding for solving problems, and these standards are very important. I think we'll see the standard TCP/IP protocol. Yeah, this is what we have discussed. The IP internet is the IP protocol. TCP is the transmission control protocol. Some protocol stacks in the TCP/IP, which is a very common protocol C. TCP/IP protocol suite. There are some examples for naming. In the application layer, you have got many applications. For example, for naming, DNS is dynamic name service. Host configuration, DHCP, Slack, and for email, SMTP, POP, IMAP are these protocols. For file transfer protocol, FTP, SFTP, TFTP, tribal file transfer protocol is TFTP, and web, HTTP, HTTPS, REST. These are the common application layer protocols. In the transport layer protocol, TCP. So TCP is connection oriented, and UDP is connectionless. This is not reliable. TCP is a reliable one, especially for file, email. We use TCP, and the web is also used TCP. UDP is for DNS, DHCP. That is not reliable, but we use it. Is fast actually. The UDP is faster. The internet layer, we have got many protocols in the internet layer. For example, you have got IP version 4, NAT, IP version 6, ICMP, the pinging protocols, some routing protocols, OSPF, AI, AIGRP, BGP are these protocols in the network layer. And we have the network access layer. We have address resolution protocols, data link protocols, Ethernet, WLAN. These are wireless local area network. Ethernet is the cable, the RJ45 cable connection. It is in this protocol. So why are these layered? Because in data, I will show you what is data. Data, when a packet is actually propagating in the networking, it has to have these protocols. So these protocols are actually zeros and ones. So the network access part, if it is, for example, Ethernet, it has its own code for that. So in each packet, you need this, what we call zeros and ones, or format or protocols. So when you go up, you need what we call the IP address, source IP address, destination, some additional protocols, TCP, source transport port and destination port, and the application layer, what type of application, what is actually holding that, or for viewing that message, what is the application being used. For example, if it is web, it can be HTTP or. But these layers are actually some data, the zeros and ones. They are represented by zeros and ones. So for clarity purpose, we say HTTP, blah blah. But HTTP is represented by zeros and ones in the packet or in the switch. I think I will explain that one in the coming. So when we say TCP/IP communication, you have got, you see, at the beginning you may need the Ethernet if it is actually visible. Let me bring this one. So let me show you. Okay. So if I have data, which is data, so that data, zeros and ones. These zeros and ones, it can be image or text or any. So this data, when we want to send it to the destination or to the receiver, we have to add this Ethernet, IP, TCP. So what we add here is just zeros and ones. For example, for TCP, some zeros and ones, or protocols. For IP, for Ethernet. So these are the protocols. The Ethernet part is used somewhere in the communication between the devices, and the IP is for routing purpose, and the TCP is for reliability between the in-between communication. So these protocols are important. For interconnecting actually your network. So you see, you have that data, and TCP header is padded to it, and then you have that IP header is padded to it. Then Ethernet is. This is at the sending. At the receiver, you have to actually decapsulate, encapsulation and decapsulation. It has to be encapsulated at the transmitter, and at the receiver it has to be decapsulated. But these are zeros and ones. These are. How are they known? For example, if it is IP address or blah blah, they need some coding. So where that, for example, where that the Ethernet part of the zeros and ones for the Ethernet start, they do have some coding to understand it. So after some preamble, you start Ethernet, and then after some, because the Ethernet header is known, how many bits that header is known, and then after that you get the IP header is known, how many bits that IP address is, and the TCP, and then it continues like that. So these are what we call protocols for communication purpose. Okay, so let's see how data is encapsulated in network. So we have got what we call data. This data is the important thing is data. So we need to actually transport data from the source to the destination. This data is zeros and ones. Normally data when we say data, the zeros and ones information at its beginning is analog, so it has to be converted into digital for digital communication or for what we call network communication. So when we talk data, these are the zeros and ones. So the zeros and ones have to be converted into analog so that we can actually interpret them by our ears or hear them see them with our eyes. But data, the zeros and ones are the important thing. So what we transmit is this data from the source to the destination. So these ones are zeros and 1, 0, 1, blah, blah, blah. This data can be video, audio, or text. So this data, when we want to transmit it from the source to the destination, we need what we call protocols. So the protocols has to be embedded in the data. So when we say that these protocols are going to be embedded, so we have what we call headers, header encapsulation. First we have data, and we add to this data, we add a header, which is actually TCP header. This TCP is zeros and ones, but it is known protocol. But computers just see zeros and ones, and this goes to, this will be data for the IP. So including the TCP and the data, I've got this data. It is data for the IP. So we add some encapsulation here, IP header. And the whole thing, the whole IP header with this TCP blah blah data will be encapsulated for what we call frame. So we add here frame header or Ethernet sometimes commonly, but it is layer 2 header, MAC header, sometimes they call it MAC header. So frame header. So for the frame, the data is the whole IP packet. So we have got this one at the beginning. This is called data. Then you have TCP encapsulated data. It is called segment. It's just a naming actually, segment. And this TCP segment with IP header is called packet. Then this IP with a frame header is frame. This is naming in data communication. So what is happening to the data? We are encapsulating actually the data by some headers. These headers are protocols or rules. TCP is one protocol, IP is another protocol, frame is another protocol. So the frame is layer 2 actually, layer 2 or access protocol. In this we have got source and destination MAC addresses, some additional protocols, language, blah blah, type of frame, what type of frame it is being used. And when we go to the IP, we have got source and destination IP addresses and some additional language or type of IP. Is it IP version 4, IP version 6? And in the TCP, we have got two types of transmission control protocols. Is it UDP or TCP? And TCP port number or UDP port number, destination port number, source port numbers are embedded here. Data is just real data. The important thing is this data, but it has to be encapsulated or covered when it is transported or transmitted through the network or through the communication. So this data has to be actually decapsulated at the receiver. It is encapsulated at the transmitter before it is being sent. Then at the receiver, it will be decapsulated. The same process. The reverse process will actually happen at the receiver, and then the important thing is the data which is actually being transmitted in this